The final chapter is on database administration and security. Chapter shows you the basis for a successful database administration strategy. Such a strategy requires the data be treated and managed as a valuable corporate asset. The chapter you will learn about important data management issues by looking at the managerial and technical roles of the database administrator. It also explores data security issues such as confidentiality, integrity, and availability of data. Alright, in Chapter 1 of this database systems, you learn that data are the raw material from which information is produced. Therefore, in today's information-driven environment, data are valuable assets that require careful management. Efficient asset management is critical to the success of any organization. To manage data as a corporate asset, managers must understand the value of information. For some companies, such as credit reporting agencies, their only product is information, and their success is solely a function of information management. Most organizations continually seek new ways to leverage their data resources to get greater returns. This leverage can take many forms, from data warehouses that support improved customer relationships to tighter integration with customers and suppliers in support of the electronic supply chain. As organizations become more dependent on information, its accuracy becomes more critical. Dirty data, or data that suffers from inaccuracies and inconsistencies, becomes an even greater threat. Data can become dirty for many reasons. Lack of enforcement of integrity constraints such as not null, uniqueness, and referential integrity. Data entry errors and typographical errors. Use of synonyms and homonyms across systems. Non-standard use of abbreviations and character data. Different decompositions of composite attributes into simple attributes across systems. Some causes of dirty data, such as improper implementation of constraints, can be addressed within an individual database. However, addressing other causes is more complicated. Some dirty data come from the movement of data across systems, as in the creation of a data warehouse. Efforts to control dirty data are generally referred to as data quality initiatives. Data quality is a comprehensive approach to ensuring the accuracy, validity, and timeliness of data. This comprehensive approach is important because data quality involves more than just cleaning dirty data. It also focuses on preventing future inaccuracies and building user confidence in the data. While data quality efforts vary greatly from one organization to another, most involve a data governance structure that is responsible for data quality, measurements of current data quality, definition of data quality standards in alignment with business goals, implementation of tools and processes to ensure future data quality. A number of tools can assist in data quality initiatives. In particular, data profiling and master data management software are available from many vendors. Data profiling software gathers statistics, analyzes existing data sources and metadata to determine data patterns, and compares the patterns against standards that the organization has defined. This analysis can help to assess the quality of existing data and identify sources of dirty data. Master data management software helps to prevent dirty data by coordinating common data across multiple systems. MDM software provides a master copy of entities such as customers that appear in numerous systems throughout the organization. Alright, the data information decision-making cycle. Alright, that's figure 15.1 in your book on page 671. It didn't quite make it, the image didn't make it into the slides for some reason. Did Decisions made by high-level managers triggers actions within the organization's lower levels. Such actions produce additional data to be used by monitoring company performance. In turn, the additional data must be recycled within the data information decision framework. Thus, data form the basis for decision-making, strategic planning, control, and operations monitoring. Alright, so need for the role of databases in an organization. At your top management level, you want to enable strategic decision making and planning, identify growth opportunities, define and enforce organizational policies, reduce cost and boost productivity, and provide feedback. At the middle management level, deliver the data required for tactical planning, monitor the use of resources, evaluate performance, and enforce security and privacy of data in the database. At the operational management level, you want to represent and support company operations, produce query results within specified performance levels, and enhance the company's short-term operations. Alright, the introduction of a DBMS represents a big change and challenge. Throughout the organization, the DBMS is likely to have a profound impact, which might be positive or negative depending on how it is administered. For example, one key consideration is to adapt the DBMS to the organization rather than forcing the organization to adapt to the DBMS. The main issue should be the organization's needs rather than the DBMS's technical capabilities. However, the introduction of a DBMS cannot be accomplished without affecting the organization. The flood of new information has a profound effect on the way the organization functions and therefore on its corporate culture. The introduction of a DBMS has been described as a process that includes three important aspects. The technological aspects include selecting, installing, configuring, and monitoring the DBMS to make sure that it efficiently handles data storage, access, and security. The personnel in charge of installing the DBMS must have the technical skills to provide or secure adequate support for various users of the system, programmers, managers, and end users. Therefore, database administration staffing is a key technological consideration. The managerial aspect of the DBMS introduction should not be taken lightly. A high-quality DBMS does not guarantee a high-quality information system, just as having the best race car does not guarantee winning a race. The introduction of a DBMS requires careful planning to create an appropriate organizational structure and accommodate the personnel responsible for administering this system. The structure must also be subject to well-developed monitoring and control. The cultural impact of the new database system must be assessed carefully. The DBMS is likely to have an effect on people, functions, and interactions. For example, additional personnel might be hired, new roles might be allocated to existing personnel, and employee performance might be evaluated using new standards. A cultural impact is likely because the database approach creates a more controlled and structured information flow. Department managers who are accustomed to handling their own data might surrender ownership and share their data with the rest of the company. Alright, the evolution of database administration. Excuse me. Data administration has its roots in the old decentralized world of the file system. The cost of data and managerial duplication in these systems gave rise to centralized data administration known as the Electronic Data Processing or Data Processing Department. The DP department's task was to pool all computer resources to support all departments at the operational level. DP administrators were given the authority to manage all company file systems as well as resolve data and managerial conflicts created by the duplication and misuse of data. The advent of the DBMS and its shared view of data produced a new level of data management sophistication and led the DP department to evolve into an information systems department. The responsibilities of the IS department include a service function to provide end users with data management support, a production function to provide end users with solutions for their information needs through integrated applications or management information systems. The function of the IS department was reflected in its internal structure. As demand grew, the IS application development segment was subdivided by the type of system it supported: accounting, inventory, marketing, and so on. As the number of database applications grew, data management became increasingly complex, thus leading to the development of database administration. The person responsible for control of the centralized and shared database became known as the Database Administrator, or DBA. The IS department's internal organization should be on this slide. I don't know why none of these images are loaded, but it is figure 15.2 in your book. You have your information system, your application development, and your database operations. 15.3 is the placement of the DBA function. There is no standard for how the DBA function fits in an organization's structure, partly because the function itself is probably the most dynamic of any in an organization. In fact, the fast-paced changes in DBMS technology dictate changing organizational styles. Alright, so some DBA functions. DBA operations are commonly defined and divided according to the phases of the database life cycle. Wow, they got none of that stuff in here. Okay. So database planning, including the definition of standards, procedures, and enforcement. Database requirements, gathering, and conceptual design. Database logical and transaction design. Database physical design and implementation. Database testing and debugging. Database operations and maintenance, including installation, conversion, and migration. Database training and support, and data quality monitoring and management. 15.4 in your book on page 677 shows your DBA functional organization. Keep in mind that a company must have several incompatible DBMSs installed to support different operations. A variety of personal computer DBMSs might be installed in different departments. In such an environment, the company might have one DBA assigned for each DBMS. The general coordinator for all DBAs is sometimes known as the systems administrator. The table that it's talking about here, I don't know exactly where that's at. Oh, it's on page 678 in your book. If you want to look over that, contrasting activities between a data administrator and a database administrator. And then your desired DBA skills is on page 680. Has managerial and technical skills that are desired for a database administrator. I'll let you look over those yourself. Okay, DBA's managerial roles. As a manager, the DBA must concentrate on the control and planning of database administration, coordinating, monitoring, and allocating database administration resources, such as people and data, defining goals, and formulating strategic plans for database administration. They have to do planning, organizing, testing, monitoring, and delivering for the end user support, policies, procedures, and standards, data security, privacy, and integrity, data backup and recovery, data distribution and use. Okay. I think it mentioned here at the bottom the data security officer. A DSO sole job is to ensure data security integrity. In large organizations, the DSO's activities are often classified as disaster management. Disaster management includes all of the DBA activities designed to secure data availability following a physical disaster or a database integrity failure. Disaster management includes planning, organizing, and testing of database contingency plans and recovery procedures. The backup and recovery measures must include at least the following: periodic data and application backups. Some DBMSs include tools to ensure automatic backup and recovery of the database. Products such as IBM's DB2 allow different types of backups: full, incremental, and concurrent. A full backup, also known as a database dump, produces a complete copy of the entire database. An incremental backup produces a backup of all data since the last backup date. A concurrent backup takes place while the user is working on the database. They also have to have proper backup identification, convenient and safe backup storage, physical protection of both hardware and software, personal access control to the software of a database installation, insurance coverage for the data in the database. Data recovery and contingency plans must be thoroughly tested and evaluated, and they must be practiced frequently. So-called fire drills should not be disparaged, and they require top-level management support and enforcement. A backup and recovery program is not likely to cover all components of an information system. Therefore, it is appropriate to establish priorities for the nature and extent of data recovery. Data are useful only when they reach the right users in a timely fashion. The DBA is responsible for ensuring that the data are distributed to the right people at the right time and in the right format. These tasks can become very time-consuming, especially when data delivery capacity is based on a typical applications programming environment where users depend on programmers to deliver the programs that access the database. Although the Internet and its intranet and extranet extensions have opened databases to corporate users, they have also created a new set of challenges for the DBA. The DBA's technical role requires a broad understanding of DBMS functions, configuration, programming language, and data modeling designs and methodologies. Many of the DBA's technical activities are a logical extension of the DBA's managerial activities. For example, the DBA deals with database security and integrity, backup and recovery, and training and support. The technical aspects of the DBA's job are rooted in the following areas of operation: evaluating, selecting, and installing the DBMS and related utilities, designing and implementing databases and applications, testing and evaluating databases and applications, operating the DBMS utilities and applications, training and supporting users, and maintaining the DBMS utilities and applications. The use of cloud-based data services does not signal the end of DBAs, but it does have a significant impact on their role. As discussed in previous chapters, services such as Microsoft Azure and Amazon Web Services allow for the outsourcing of database technology as a highly scalable capability on-demand service. As a result, the DBA has a reduced role in installing and maintaining the DBMS. DBMS installation and updates. The DBMS is installed on a virtual server by the service provider. As the DBMS vendor releases required updates and security fixes to the DBMS software, the service provider manages the application of the updates within a specified maintenance window. Server network management. The service provider configures and manages the server where the DBMS resides, including scaling a database across multiple servers as needed. If the database is distributed across multiple servers, the service provider can supply load balancing to ensure a high level of performance. Backup and recovery operations. The service provider performs regular backups and stores backups in secure facilities. Security refers to activities and measures that ensure the confidentiality, integrity, and availability of an information system and its main asset, data. Securing data requires a comprehensive company-wide approach. To understand the scope of data security, you have to consider the goals. Confidentiality deals with ensuring that data are protected against unauthorized access, and if the data are accessed by an unauthorized user, that the data are used only for an authorized purpose. Compliance refers to activities that meet data privacy and security reporting guidelines. These guidelines are either part of internal procedures or are imposed by external regulatory agencies such as the federal government. Integrity within the data security framework is concerned with keeping data consistent and free of errors or anomalies. The DBMS plays a pivotal role in ensuring the integrity of the data in the database. However, from the security point of view, the organizational processes, users, and usage patterns also must maintain integrity. Availability refers to the accessibility of data whenever required by authorized users and for authorized purposes. To ensure data availability, the entire system must be protected from service degradation or interruption caused by an internal or external source. Service interruptions can be very costly for companies and users alike. System availability is an important goal of security. Normally, the tasks of securing the system and its main asset, the data, are performed by the database security officer and the database administrators, who work together to establish a cohesive data security strategy. Such a strategy begins with defining a sound and comprehensive security policy. A security policy is a collection of standards, policies, and procedures created to guarantee the security of a system and ensure auditing and compliance. The security audit process starts by identifying security vulnerabilities in the organization's information system infrastructure and identifying measures to protect the system and data against these vulnerabilities. A security vulnerability is a weakness in a system component that could be exploited to allow unauthorized access or cause service disruptions. Such vulnerabilities could fall under one of the following categories. Technical, an example will be a flaw in the operating system or web browser. Managerial, for example, an organization might not educate users about critical security issues. Cultural, users might hide passwords under their keyboards or forget to shred confidential reports. And procedural, company procedures might not require complex passwords or the checking of user IDs. When a security vulnerability is left unchecked, it could become a security threat, and a security threat is an imminent security violation. Alright. A security breach occurs when a security threat is exploited to endanger the integrity, confidentiality, or availability of the system. Security breaches can lead to a database whose integrity is either preserved or corrupted. Preserved, in these cases, action is required to avoid the recurrence of similar security problems, but data recovery may not be necessary. As a matter of fact, most security violations are produced by unauthorized and unnoticed access for information purposes, but such snooping does not disrupt the database. Corrupted, action is required to avoid the recurrence of similar security problems, and the database must be recovered to a consistent state. Corrupting security breaches include database access by computer viruses and by hackers who intend to destroy or alter your data. The table that's supposed to be on this slide is on page 693 in your book, and I'll let you guys look over that on your own, where it talks about sample security vulnerabilities and related protective measures. Excuse me. Alright, so database security refers to DBMS features and other related measures that comply with the organization's security requirements. From the DBA's point of view, security measures should be implemented to protect the DBMS against service degradation and to protect the database against loss, corruption, or mishandling. Um, Protecting the data in the database is a function of authorization management. Authorization management defines procedures to protect and guarantee database security and integrity. User access management is the function designed to limit access to the database. It's likely to include at least the following procedures, where you define each user to the database, assign passwords to each user, define user groups, and assign access privileges, and control physical access to the actual machines. Your view definition is the DBA must define data views to protect and control the scope of the data that are accessible to an unauthorized user. DBMS access control. Database access can be controlled by placing limits on the use of DBMS query and reporting tools. DBMS usage monitoring. The DBA must also audit the use of data in the database. Several DBMS packages contain features that allow the creation of an audit log, which automatically records a brief description of database operations performed by all users. The integrity of a database could be lost because of external factors beyond the DBA's control. For example, the database might be damaged or destroyed by an explosion, a fire, or an earthquake. Whatever the reason, the specter of database corruption or destruction makes backup and recovery procedures crucial to any DBMA. Alright, it talks about a data dictionary. A data dictionary is a component that stores the definition of data characteristics and relationships. You have integrated and standalone. An integrated data dictionary is included with the DBMS. Or a DBA may use a standalone or third-party system. Data dictionaries can also be classified as active or passive. An active data dictionary is automatically updated by the DBMS with every database access to keep its access information up to date. A passive dictionary is not updated automatically and usually requires running a batch process. Data dictionary access information is normally used by the DBMS for query optimization. The data dictionary's main function is to store the description of all objects that interact with the database. Integrated data dictionaries tend to limit their metadata to the data managed by the DBMS. Standalone data dictionary systems are usually more flexible and allow the DBA to describe and manage all of the organization's data, whether they are computerized or not. Whatever the data dictionary's format, it provides database designers and end users with a much improved ability to communicate. Alright, CASE is the acronym for the Computer Aided Systems Engineering. A CASE tool provides an automated framework for the system development lifecycle. CASE uses structured methodologies and powerful graphical interfaces. Because they automate many tedious system design and implementation activities, CASE tools play an increasingly important role in information systems development. CASE tools are usually classified according to the extent of support they provide. For example, front-end CASE tools provide support for the planning, analysis, and design phases, and back-end CASE tools provide support for the coding and implementation phases. A typical CASE tool provides 5 components: graphics designed to produce structured diagrams such as data flow diagrams, ER diagrams, class diagrams, and object diagrams; screen painters and report generators to produce the information system's input and output formats; an integrated repository for storing and cross-referencing the system design data. This repository includes a comprehensive data dictionary; an analysis segment to provide a fully automated check on system consistency, syntax, and completeness; a program documentation generator. Alright, so developing a data administration strategy. For a company to succeed, its activities must be committed to its main objectives or mission. Therefore, regardless of its size, a critical step for any organization is to ensure that its information system supports its strategic plans for each business area. Alright, so information engineering allows for translation of the company's strategic goals into the data and applications that will help the company achieve the goals. IE focuses on the description of corporate data instead of the processes. The rationale is simple. Business data types tend to remain fairly stable, but processes change often and thus require frequent modification of existing systems. By placing the emphasis on data, IE helps decrease the impact on systems when processes change. An output of the IE process is an information system architecture that serves as the basis for planning, development, and control of future information systems. The success of the overall information system strategy and data administration strategy depends on several critical success factors that the DBA needs to understand. Management commitment is the commitment of top-level management. It's necessary to enforce the use of standards, procedures, planning, and controls. Thorough analysis of the company situation. The current state of the corporate data administration must be analyzed to understand the company's position and to have a clear vision of what must be done. End-user involvement. What degree of organizational change is involved? Successful change requires that people be able to adapt to it. Users should have an open communication channel to upper management to ensure success of the implementation. Good communication is key to overall process. Define standards. It's not in the slides, but define standards. Analysts and programmers must be familiar with appropriate methodologies, procedures, and standards. If not, they need to be trained. Training. The vendor must train DBA personnel in the use of the DBMS and other tools. End users must be trained to use the tools, standards, and procedures. Key personnel should be trained first so they can train others. A small pilot project is recommended to ensure that the DBMS will work in the company, that it produces expected output, and that the personnel have been trained properly. Using Oracle for database administration. We didn't really go over Oracle in this class, so I don't think I'm going to go over this last section about using Oracle. You're welcome to read it on your own. If you have questions on it, let me know.